Alright, so we have some closing tasks. This is just using the trapezoid again, isosceles trapezoid. And it says use angle P, I guess, to find angle R, which isn't too bad because you know that these guys add up to 180, which makes this 103. And then you know the base angles of an isosceles trapezoid are the same. So this is 103 and this is 77, and we're done. This one says that JL is 3y plus 6. It says KM is 22 minus y. And we know for an isosceles trapezoid which this is, right? Oh no, we don't know that. It says determine if it's an isosceles trapezoid. Well, if it is, these guys will be equal. So let's see if they're equal. We got 3y plus 6. Let's see if it can equal 22 minus y. And what value of y would make it equal? So we subtract y, we get 2y plus 6 equals 22. Subtract 6, 2y equals 16. And y would equal 8 if this was to be equal. So if I said 3 3y plus 6, so it's, did I do something wrong here? Let me see if I did. Oh, you know what? I should have added y, which would give me 4y, and that would give me y equals 4. So let's plug it in. 3 times 4 plus 6 is 12, 18, and definitely 22 minus 4 is 18. So a value of 18 for y would give us an isosceles trapezoid. There's one more theorem, and it's a mid-segment theorem. So if you draw a segment whose endpoints are the mid-segments of the legs, that means halfway through these legs, right, making 2. Here's the lengths. This is half the sum of those. So if I made this x and this y, that would be x plus y divided by 2. So if I was down here and I wanted to find out this length, right, I would add them. I'd go 10.3 plus 12.5 and divide that by 2 to get this length right here, which would be 22.8 divided by 2, which would give me 11.4. That said, let's go ahead and write that. If I was going to do leg 1 plus leg 2 divided by 2 gives me the midpoint, it'll help us set it up. If they give us the midpoint, right, rather than a base, I said base, a leg, I should have said base 1 and base 2. So in this situation, they only give us the base and the midpoint. So I would say base 1, which is 8.3, plus base 2, which I don't know, it's this bottom one, divided by 2 equals the midpoint, which we have a 9.8. Well, and then we just solve with algebra, right? If I multiply by 2, I got 8.3 plus that base 2 is equal to, what do we got? 19.6. If we subtract 8.3 minus 8.3, we get that base 2 is equal to 11.3. So that would be our answer. This would be 11.3. We could check our answers by adding that together and dividing it in half. Alright, so we got that base, that midpoint. And there's one more here. Look at this right here. They said in a trapezoid, right, PQ is twice the RS. So if that's PQ here, 16.8, it's double this, which would make this 8.4. And then they want us to find this middle line right here. So I would say my midpoint, my midsection, is equal to those added together, 16.8 plus 8.4, and we're going to go right in the middle, so we divide it by 2. So my midpoint is equal to, what was that, 23.2 divided by 2? Nope, I did that wrong. 25.2 divided by 2, which means that midsection is going to be 12.6. Right there is 12.6. And then we just have this. There's everything we've talked about, all our quadrilaterals. And if you want to see if everything in here was a quad in a Venn diagram, and this is the one visual I haven't given you. I haven't given you a Venn diagram. It's kind of nice to look at a Venn diagram, right? Because then you can see that everything in here is a quadrilateral. And once you get in this quadrilateral area, right, a kite's kind of by itself. It's two distinct pairs of congruent angles. Now, some books won't do this, but a trapezoid says at least one pair of parallel sides. So it is capable of being a parallelogram. If I had two parallel sides, a trapezoid's capable. It makes the Venn diagram a little tough. Then we get what we've been talking about. Parallelogram is two pairs of parallel sides. If those have four right angles, they're a rectangle. If they have four congruent sides, it's a rhombus. And if they have all of them, it's a square. Now, so let's come down here. Isosceles trapezoid theorem about congruent diagonals is a form of a biconditional statement. Is it possible to state the two isosceles trapezoids theorems about the base angle as a biconditional statement? Well, let's say, and we'll talk about this, but I want you to think about this and write an answer down here. Alright, so this is yours. Think about it. Do not skip this. Alright, an essential question. Do kites and trapezoids have property that are related to their diagonals? Think about that. They do, by the way. See if you can pull that. What are they? What are they? Try to do it without looking at your notes. Kites and trapezoids have properties, or at least some trapezoids do, right? So, but kite has a few that are related to their diagonals. So think about it. All right, see if you can pull it from memory. And I will see you guys soon.